This project is an EMP-resistant transport case for sensitive communications equipment sponsored by Miltech. Military equipment failures in hostile environments can cost lives. The cases carrying these types of equipment must be able to survive any and every obstacle thrown at them. The Penn State team set out to design a case that keeps mission-critical gear protected even in the harshest conditions. In designing our case, we were told it had to be rugged, watertight, shock-absorbing, and EMP compliant to military standards. Internally, it needed organized storage, shock protection, and chemical resistance. We prioritized modularity, quick repairs, and field-friendly manufacturing like additive printing. We began by analyzing existing designs and decided our focus areas should be on weak latches, rigid corners, and poor EMP shielding. Early sketches explored shape, structure, and user-friendly improvements based on feedback. We eventually settled on our third prototype, adding valleys, increasing rigidity, and designing for full part symmetry. In other developments, we added a pressure sensor system using Arduino to show when internal gear is seated properly. We also implemented a solar trickle charger to maintain battery power without manual recharging into our design. When it came to printing our various prototypes, we used a QIDI 4 Plus printer to fine-tune models for our test materials and flexible TPU components. We tested 4 materials under extreme temperatures and shock scenarios: ABS, ASA, PETG, and PETG carbon fiber. Testing followed military standard drop protocols. Multiple drops in hot and cold conditions. After extensive testing, ABS was the clear standout. It resisted cracking and stayed stable throughout the entire testing period, proving its durability for real missions. When it came time to print out scale models, we quickly learned of the challenges of large-scale printing. Finding a machine to print our case was hard, and finding a contractor willing to take on the project was even harder. This revealed to us one thing: large prints were slow and expensive, presenting challenges in scalability and speed in potential military applications. Unfortunately, one case cost over $4,600 to produce. Costs drop slightly with scale, but printing remains pricey. Despite that limitation, there are things we can take away from this amazing experience. We learned the value of procurement planning and how complex additive manufacturing really is. We also learned of the value of time management, especially in a project of this magnitude with so many moving parts. In the future, improvements like mold-based manufacturing, smarter inserts, and sustainability upgrades can be made in the latest iteration of the case to further enhance the effects we worked so hard to achieve. I am proud to say that in the end, we made exactly what we set out to make: an EMP-resistant transport case, engineered for the field, designed